What is absolute temperature? It's a cool topic to discuss because understanding this topic will have a fast conclusion uh, about ideal gas law and gas equation. What is gas constant? So absolute temperature is the forerunner to learn all about pressure, temperature, and everything. So what is absolute temperature? So absolute temperature is a temperature that actually solidifies most atoms, solidifies lot, I mean all the atoms perhaps present in the universe. So just a theoretical temperature. It is not achieved by anyone else, but it's a theoretical temperature that is claimed to I mean any place. If this temperature is reached, the atoms will stop moving, and atoms will have no movement at all. The atom or ceased atoms are ceased. So in this case, atoms uh, becomes solidified, becomes solid, actually becomes solid, and no movement. And so in this case, atom cannot make another, it no more hopping. It cannot it cannot be a liquid, it cannot be a gaseous state. So all atoms under arrest. So this is the absolute temperature. So what is the temperature? It's 0 degree Kelvin, or 0 degree Kelvin. It's not okay, actually. It's 0 degree Kelvin, or minus 273 degree 273 degree Celsius. So normal day out there in any town or any city, it's almost 25 degrees Celsius around the world. But imagine if it is minus 273 degrees Celsius, how much cold it would be. It is a maximum cold that any object or any place can reach. It's been said theoretically, it's not reached anywhere, but this theoretic temperature, if it is reached anywhere else, the place has become seized. That is, all molecules become, we cannot say it's died, actually. It becomes motionless. It's become motionless. And uh, and uh, this term is known as entropy. Actually, entropy is the randomness. I mean, the degree of randomness, or how molecules can really become weird, become behave so much playful when it is disturbed, or when it is perturbed. So this at this state of minus 273 degrees Celsius, so molecules becomes so calm. I mean, it just becomes seized, actually. So how it is going to happen? Let's see in the periodic table. This periodic table helped me to understand the about chemistry, the properties of elements and everything. So let's discuss here. Uh, let's say state at 2193. I mean, this is the one that really helps us to understand the properties of molecule. Let's say. So what is that? So temperature. Let's say temperature of degree 25 degrees Celsius. So when it is 25 degrees Celsius, it's almost 298 degree Kelvin. So 298 degree Kelvin. So let's put 298 degree, because it is given in the Kelvin scale. So 297, that's okay. It's not about 1 Kelvin. So at this 297 degree Kelvin, so we see that hydrogen and helium and all the noble gases and the part of these gases are largely remain gaseous state, and just two, bromine and mercury, are in liquid state, and all other elements are in solid state. So what happens if we go down with the temperature? Let's say you see that, so the black one is all solid, and the blue color, it's liquid, and the red one is the gas. What happens if we further go down? We go down. So 297 Kelvin, we are further going down to 238. We see that. Uh, we see that a lot of disappearance there out in the liquid. Yes, sorry, in the gases. And further going to 178 Kelvin, and 149 Kelvin, 190 Kelvin. What is 100 Kelvin, by the way? Let's say 100 Kelvin. 100 Kelvin, so it's minus 173 degrees Celsius. Perhaps we cannot just able to find the temperature anywhere exists. So, but theoretically, minus 173 degrees Celsius, only hydrogen, helium, neon, argon can be, fluorine, and oxygen can be in gaseous state, and all other atoms will cease their motion. By minus 173 degrees Celsius, that is 119 Kelvin. So we go down further, 59. So I mean, just hydrogen, helium, and neon will have it motion, and oxygen and fluorine will be in a liquid state. Let's further go down. The oxygen, if you see oxygen, only pure oxygen, O2, with only oxygen, if it goes into liquid state, that is in just 59 Kelvin. So further going down to 0 Kelvin, we find that all molecules, all the atoms become seized. That is, it's become in rest, actually, completely, would have no motion. But this temperature, now imagine that this temperature will never be achieved in the real world, in the real universe. It's never seen in the real universe. It's such a monumental understanding you need to have when you try to understand about what is ideal gas and what is the property of gas equation. So this is so very pivotal to understand what is an absolute temperature. Thank you.